In this lesson, we will review how to solve systems of equation. The goals of the lesson are to determine the number of solutions to a system of equations, to use 3 methods to solve a system of equations, and to review SAT problems that require solving systems. When we talk about the number of solutions, it could result in 3 different ways. We could get one solution, infinite solutions, or no solutions. Some examples for one solution, what's going to happen is that our 2 equations of the line will intersect one time. Where they intersect gives us our one solution. When we have infinite solutions, what happens is as we graph both lines, they end up in the exact same position. Now remember, every time that these lines cross, they produce a solution. And that's why we can say that these have infinite solution, because as we know from geometry, these lines would go on forever. And then finally, when we have no solution, an example of that would be when we get parallel lines. Parallel lines will never intersect, and therefore they would produce no solution. Now we can solve systems of equations with 3 different methods. We can either solve them by graphing, by substitution, or by elimination, and we'll go through all 3 of these now. So we'll start off with solving systems by graphing. In our first example, we start with y equals negative 2x plus 1. As we reviewed in the previous lesson, we would want to start out with our b value here. Because our y-intercept is 1, we can plot that at 1. Now our slope is negative 2, so that's going to tell us to go down 2 and over 1, and we can plot that line. Again, it's important that we use a straight edge, especially with this type of section. With our other line here, which I'm going to show in red, this one is going to have a y-intercept at 4, so I'll make a point at positive 4. Its slope is going to be 1, so we're going to see that this is going to be a positive line going up 1 over 1, and we'll graph that. Now again, wherever these lines cross, that will be the solution. So since they cross right there, and that's at negative 1, comma 1, 2, 3, negative 1, comma 3 would be our solution. It's important that we then test the value for both equations. So we would want to take this as an x value and this as a y value and plug it into the top equation. That would give me negative 2 times negative 1, so 2 plus 1, meaning that I get 3 on this side. Well, since my y value here would be 3, that balances that equation. For my second one, if I plug in a negative 1 here, negative 1 plus 4, that gives me 3. I do have a 3 on the other side, so that does balance the equation. Okay, so here's an example of how we would solve by substitution. What we want to do here is if we have one of the variables already solved for, which we do here, we're going to take its quantity, so in this case, negative 7x minus 1, and we're going to substitute or fill that in for this y value right here. So what I end up getting is I leave the negative 5x alone. I leave the minus alone. When we plug something in, if it's a quantity here, if it's a binomial here or a trinomial, anything like that, we want to keep it in parentheses here because it's going to be important that in a minute, we will be distributing that negative in. This side is not going to be affected by that, so we just leave equals 1. From here, we can go ahead and distribute the negative to both. That gives us negative 5x plus 7x plus 1 equals 1. We can combine like terms here, which gives us 2x plus 1 equals 1. We want to move our constant over. Subtracting 1 is going to give us 2x is equal to 0. Now, one thing I want to mention with this is that having our constants drop out is not the same thing as when our variables drop out. If we lose our variables, it's a special case. If we lose our constant, 1 minus 1 is still just 0. I still have an x in this problem, so I will get an answer here. Next step is to divide both sides by 2. We end up getting x is equal to 0. But remember that we're looking for an ordered pair here. So getting x is just part of the solution here. We're now going to take this x value and plug it into either one of these equations. It doesn't matter which one, but a lot of times since we're trying to solve for y here, it would make the most sense to plug it into this expression. So if I do that, I get y is equal to negative 7. Instead of an x, I'm plugging in what we know its value is now, which is 0, and then minus 1. Negative 7 times 0 will just be 0, so I have 0 minus 1, which gives me negative 1. So right now we're thinking that the answer is 0, negative 1. But it's important, again, that we test the value for both equations. So if I plug that into the top one, negative 5 times 0, that's going to be 0. Minus the negative 1 will turn into a positive 1, which makes the equation true. And then for the bottom one, I'd have negative 1 on this side for y. Negative 7 times 0 would cancel. That would just be 0 minus 1. So I get negative 1 equals negative 1. Since it's true for both, we can say that 0, negative 1 is the correct solution. And finally, we'll look at solving systems by elimination. Here we can see that we have our x's lined up, our y's lined up, and our constants on the other side of the equation, and they're lined up. What we want to do here is figure out how to cancel either the x's or the y's. So here, what's going to make more sense is to cancel our y's. We can't manipulate just this y without changing this entire equation. So since this is going to need to turn into a 2, we multiply that whole bottom equation by 2. So I'll rewrite the top equation, negative 10x minus 2y is equal to negative 16. And the bottom equation, as I distribute the 2 to every single value here, is going to be 18x plus 2y is equal to 40. From here, I can start to add each of these columns here. So negative 10x plus 18x is going to give us 8x. The negative 2y and 2y canceled, and then negative 16 plus 40 is 24. Next up is to divide both sides by 8, and that's going to give us x is equal to 3. And once we get that x is equal to 3, we can take that and plug it into either of these equations here. You can actually plug it into this top one, this bottom one here, or you could even use the one that starts with 18x right here. This would be my last option though, because although it would work, we do have bigger numbers involved here than we do in either of these. So I chose to use the top equation here. So we get negative 10 times our x value, which is 3, minus 2y is equal to negative 16. This is going to give us negative 30 minus 2y equals negative 16. We don't have to combine the variable with anything, so I'm going to leave that alone. I am going to move this negative 30 over to the other side by adding 30. We get negative 2y is equal to 14. We divide both sides by negative 2, and we get y is equal to negative 7. Now again, we really need to check those solutions. So if I take a minute to do negative 10 times 3, that's negative 30. Negative 2 times negative 7 is going to give us positive 14. So if I have negative 30 plus 14, it does give us negative 16. Then over here, 9 times 3 would be 27. Minus 7 would give us 20. So now we know that 3, negative 7 is a valid answer. For example 4, we're going to take this system and we're going to solve it with all 3 methods. So hopefully we realize that since it's the same system, no matter which method we're using, we should get the same outcome. Now, in order to graph this, we are going to want to put both of these into slope-intercept form, which is y equals mx plus b. So for the top one here, I'm going to get y is equal to 2x minus 1. And how I got that would be to subtract 4x on each side and then divide everything through by negative 2. The bottom one's a little easier. All we have to do here is subtract 2x, and that's going to give me y equals negative 2x minus 3. So as I graph them, top one is going to be blue. I start at, for the blue one, I'm starting at negative 1. Slope is positive, so I know it's going to go up from left to right. And it goes up 2 and over 1. And we'll connect that. Again, we want to use a straight edge. For the one that I have in red, I'm going to start at negative 3. This is a negative slope, so I know it's going to look something like that. This one goes down 2 to go over 1. And we connect. And then we look for its intersection point. Now its intersection point here might be a little bit hard to read. We can kind of see that it looks like it's maybe between grid marks here. So I'm not going to write down an exact value for this, but I'm going to see what I get for substitution and elimination and see if that kind of matches up with the value that I'm getting for graphing here. With substitution, we have a choice. You can solve for any of the variables here. We can solve for this x, this y, this x, or this y. What's always going to make the most sense is to solve for the one that has a coefficient, the number in front of it is 1. So we can do that, or we can also just set these two equal to each other. And that's what I did here. So because these are both equal to y, I'm basically taking this 2x minus 1 and plugging it in for this y here, giving me this equation here. I start by adding 2x over to each side. That's going to give me 4x minus 1 equals negative 3. I add 1 to each side. We get 4x equals negative 2. Divide both sides by 4. And negative divided by positive is negative, and then 2 over 4 will reduce to 1/2. From there, I still have to figure out what my y value would be then. So I'm going to take that negative 1/2 and I'm going to plug it into the equation that we use right here, y equals 2x minus 1. So I've got 2 times my x value that I just got, the negative 1/2, and then minus 1. Well, 2 times negative 1/2 is going to be negative. The 2's are going to cancel, and I'm going to end up just getting negative 1 minus 1, which is negative 2. And then finally, for the elimination here, we're going to take our original equations and determine what is going to make the most sense to cancel. In this problem, we could cancel the x's, and we would do that by multiplying the bottom equation by a negative 2. Or we can choose to cancel the y's, and we would do that by multiplying the bottom equation by 2. And that's what I did here. So I'm going to rewrite this equation. 4x minus 2y equals 2 is not changing, but the bottom one is. If I distribute that 2 to everything, I end up getting 4x plus 2y is equal to negative 6. From there, if I cancel out my y's, I'm left with 8x is equal to negative 4. I'll then divide both sides by 8. Remember that this is not 8 divided by negative 4. It's negative 4 divided by 8. It's going to stay negative, and then 4 over 8 reduces to 1/2. So it's good that our x values are checking out so far. Now we'll take this negative 1/2 and I can plug it into any of the equations here, either that top one, this bottom one, or the one that I got once I multiplied by 2, which again is going to be my last choice. Here I chose to use this bottom one right here. So I did 2 times our x value, which is negative 1/2, plus y equals negative 3. 2 times negative 1/2, the 2's are going to cancel. I'm left with negative 1 plus y is equal to negative 3. Add the 1, we get y is equal to negative 2, and which again checks out with this. Now, hopefully your graph turned out a little bit better than mine did. I can see that these look like they're intersecting back at about negative 1/2. Mine doesn't quite look like they're exactly at 2. However, it's just because these lines are very hard to get them to be exact on the computer. But like I said, hopefully yours looks a little bit more exact, and it should intersect at negative 1/2 comma negative 2. And that would be our final solution. Again, you could take a minute to plug that back into each of these equations, and it would check out.